and welcome everyone. In this chapter we are going to see STP port stats. So far we have seen that STP has some forwarding delay. So how that forwarding delay is going to be and what is the process of background STP algorithm. So far when it comes to the root port and designated port, they will be into the forwarding state. Of course, yes. But before going to forwarding state, the STP ports will go for several stages. Okay. So let's try to understand what are the different type of states you have and what exactly happens into those states as well. So by default what happens, the STP ports will be into disable states. It's like maybe the particular port is shut down. That's the main reason that layer 2 port does not participate into spanning tree algorithm, or you can say it does not participate into STP process and does not forward the frame, maybe shut down. The moment you define the no shutdown, the ports will go for the several stages such as this one. It will go for blocking state. And in blocking state, your switches will be receiving the BPDU up to 20 second, and it will be just receiving the BPDU and drop that. Receive the BPDU and drop that. And it will stay up to 20 second into the same. This is happen initially when you start your switch. That time your block state will be there only one time. Okay. Later on, after 20 second of this particular delay period, your switch port will go for the listening state. Okay. In listening state, your switches will send the BPDU and they will receive the BPDU, and they will do the same job for 15 seconds. So they will send the BPDU and they will receive the BPDU, and it will be happen for 15 seconds in the listening state. After 15 seconds of time, the switch ports will go for the learning state where they will receive the BPDU, send the BPDU, and also launch the MAC addresses. Means they will create its MAC address table as well, and it will be there up to 15 seconds in this particular learning state. After this learning state expire, they will go for forwarding state where they are going to send and receive the BPDU, launch the MAC addresses, and also forwards the data. So if you see in this case what's happening, basically your switch port was basically there in disable state when it was shut down, and when you give no shutdown, it will go for block state or blocking state you can say, and it will be there for 20 seconds. And this happens only one time when you start your switch. If your switch is running and if you are connecting the PCs on that, so the switch port will go for listening its state and it will be there for 15 seconds, and then it will go for learning 15 seconds. So total forwarding delay when you add, it is going to be 50 seconds of your forwarding delay when you start your switch and PC at the same time. And say for example, maybe if your some of the switch is already running and now you are connecting your PC. So in that case, your switch has already gone through disable and blocking state. Your switch will go for listening state and then learning state. So this is your 15 second, this is your 15 second. So total forwarding delay will be 30 second. Okay. So there is two condition. If you take your PC and connect to switch and start your PC and switch at the same time, it will take 50 seconds to come into the working condition. And if the switch is already running, let's say it is already running, and now you are connecting your PC here, then it will take 30 seconds, because switch has already gone through disable and blocking state. It will just go for listening and learning state, and this is called as your forwarding delay. Okay, moving ahead, say this. So far when it comes to your STP timers and all, couple of points to remember. STP hello timer, as we know, STP hello timer by default is 2 seconds. We know that BPDU in STP that will be sent in every 2 seconds by the switches. Next you have the maxes, is all about how long to keep the ports into blocking state before going to listening state, and the by default timers is 20 seconds. And the last one is forwarding delay, which is all about how long to stay into listening state before going to forwarding state, and how long to stay into learning state before going to forwarding state. That is called as 15 second. Each is 15 second. Okay. So disable to blocking, it is 20 second. So before going to listening state, it will be there up to 20 second, and before going to learning state, it will be there 15 second. Before going to forwarding state, it will be there for 15 seconds. So total that is 50 seconds of forwarding delay will be there here. So this is very important points which we need to remember. So far this forwarding delay can cause the issues, and just to avoid the same we have some of the technology, and that we will discuss in our future videos. I would like to highlight one more point, that STP has the multiple flavor, or you can say the STP has the multiple type, in which the default one is this STP, which is open standard 802.1d is the open standard which we are learning, which we have seen. After that you have the PVST plus, which is basically supported in the Cisco switches by default. STP is not there, Cisco switches has the PVST plus, and STP and PVST plus both are same mostly, which is basically designed for Cisco. Then STP has enhanced version which is RSTP, PVST has enhanced version which is Rapid PVST, and PVST and Rapid PVST both are Cisco proprietary, and rest of all open standard you will find here. Okay. And this is your convergence like fast, slow, resources needed like low, medium or high, and this is number of STP instances. Okay, STP instances is equal to STP process. For example, STP basically works based on your VLANs, If you have simple STP, and if you have just VLAN one STP process. If you have, let's say, hundreds of VLANs running, only one STP. If you have thousands of VLANs running, also only one STP. That's what here it is talking, only one STP process. One STP process in the sense one root bridge, one block port, one BPDU every 2 seconds. But when it comes to rapid PVST or maybe PVST, it is all about, in PVST it will be like one VLAN is equal to one STP process, 10 VLAN is equal to 10 STP process, hundreds of VLAN is equal to hundreds of STP process, thousands of VLAN is equal to thousands of STP process. So every STP process has its own route, its own block, its own BPDU as well. So we will see this in detail in our coming lecture, that how STP is going to be with the Cisco as PVST. Okay. So that's it for this particular lecture, guys. I will see you in the next lecture. Thank you.